In this video, I'm going to explain how to do density problems using dimensional analysis. So in this problem, this first problem, we are given a mass of 16.7 grams of gold, and the density of gold is 19.28 grams per milliliter. So what we do, like in all types of problems like this, we always start with what's given. We are given 16.7 grams, and so we start with that. So 16.7 grams, and we have grams of gold, so it's always a good idea to list all of the as much information in the units as you can. So we have 16.7 grams of gold, and then we multiply by a unit, a conversion, or an equivalent statement. And so in this case, the equivalent statement or conversion that we're going to use is the density, which is 19.28 grams per milliliter. So since we need to get rid of the units of grams of gold, we're going to put grams on the bottom, and then we want a volume, which would be milliliters, on top. And so we have 19.28, which goes on the bottom, and it's 1 milliliter on top. And then the grams will cancel, and we're left with the units of milliliters of gold, which is what we want. Putting into our calculator, 16.7 times 1 divided by 19.28 gives us 0.866, and to three significant figures, the answer is 0.866 milliliters of gold. For the second problem, we are trying to find the mass, and we're given milliliters. So this is a volume. So we want to start with what's given, 43.11 milliliters. And this is aluminum this time. We multiply by something, by a conversion factor, where we need to get rid of milliliters of aluminum. So we will put that on the bottom. And we want to find a mass, so we put grams of aluminum up top. And this conversion will be the density, because grams per milliliter is a density. Here's our density, and so it's 2.72 grams over 1 milliliter. Put this into our calculator. 43.11 times 2.72 gives us 117.2592. So this has 4 significant figures. This has 3 significant figures. So our answer should only have 3, which ends up being 117 grams of aluminum.